Hi there, but welcome back to another section of my YouTube channel, videos. So in this video, I'm going to take you through the determination of determinant of a matrix using Gaussian elimination with partial pivoting. In our previous video, we did how to determine the determinant of a matrix using naive Gaussian elimination method. So this time around, we are using partial pivoting. Please, if this is the first time you are visiting this channel, kindly subscribe to the channel and also turn on the notification button so you get updated when I post new videos like this. Let's get straight to what I have in the video. I have a theorem here which says let a matrix be n by n matrix, and I said n by n indicates a square matrix from the previous videos. Then if matrix B is a matrix that results from switching one row with another row, then the determinant of B is equal to negative determinant of A. So it means that when I give you a matrix A and you perform row operations, but among the operations you switched one row with another row, the new matrix you get will be an hypertriangular matrix whose determinant is simply found by multiplying elements on the diagonal. But that determinant you get should be negative of the original. Okay, so let's see how we do that. I'm going to give a problem here so we solve together. So the problem is find the determinant. Find the determinant of the matrix below. And the matrix is matrix A, giving us, I have the entries row wise 10, negative 7, right? 0, negative 3, 2.099, then I have this to be 6, then I have 5, negative 1, 5. So I am to find the determinant of this matrix using the partial pivoting method. So how do I start? It's the same algorithm as finding using Gaussian elimination partial pivoting. So you can visit my videos on that so you can understand all of that. So from here we move straight to using the forward elimination, which is the point of interest. Forward elimination. So when I say forward elimination, we are only trying to eliminate some of the components or the entries so that our matrix will turn into an hypertriangular matrix. So among them is this one, and this one. Those are the three I'm going to take off so that I get an hypertriangular matrix and I can easily find the determinant. So let's see. To eliminate the first column entries aside the 10, we find a multiplier, and so that way I perform my row operations. But before you start, you make sure that you scan through the entries. What is the maximum number or the highest number to be precise? Is the highest number should always be the starting of the matrix. Okay, the row which has the highest number should move up. That is one peculiar thing about partial pivoting. So before we start, you can see that 10 is the highest number here, and indeed it's starting, so we are good to go. So at this point, I'll simply have 10 next 7, 0, negative 3, 2.0996, 5, neg 1, 5. So to do this, we need our first row operation, and we can get that from what? This, I want to eliminate negative 3, so my multiplier m is simply equal to negative 3 over 10, because this row 1 is always our pivot row, multiplying row 1. Okay, then the row operation is simply my row 2, which I want to eliminate the first entry, minus, this becomes negative 0.3. Okay, so minus, so I'm having this, take note of this particular place. I'm having root 2, okay, minus, open bracket, minus 0.3 R1. Right. This is the same as root 2 plus 0.3 R1 going into row 2. So let's see how the entries will be. So with this, the entries will be simply 10 next 70, which remains. Then I'll have this place to be negative 3. So here I'll have negative 3 plus 0.3 times what? 10. And that is giving me negative 3 plus 3. That is 0. So here is 0. Then here is 2.099. Okay. 2.099 plus 0.3 times 10. What do we get? You are getting 5.099, right? So we get 5.099. Then the last part, 6. I have 6 plus 0.3 multiplying. Oh, sorry, I made a mistake here. You realize that for this side, I'll multiply 2.099 is the second. So plus 0.3 multiplying negative 7 instead, not 10. So multiplying negative 7 here. So I have 0.3 multiplying negative 7. So that's giving me 2.099 minus 0.3 times 7, right? And that's the same as 0.001. Negative 0.001. Then this part is 6. So 6 minus 0.3 multiplying with 0, right? It's the same as what 6 here. Then I close it. Then the last part is 5 minus 1, 5. So at this stage, we come back to analyze this again. So the next thing to do is to eliminate our 5 here, and we can do that simply by using our row operation. So my multiplier m is simply going to 5 over 10, right? Multiplying r1. Then I subtract this 10 from my third row. So row operation r3 minus 5 from 10 is 0.5 r1. All goes into r3. So what will be our new matrix? Row 1 maintains. Row 2 is 0, negative 0.0001. So I think I need 1, 2, 3. No, it's supposed to be 2. So 1, 2, 3. Yes, so it's supposed to be 2 zeros here. So negative 0.0016. Then here becomes 5 minus 0.5 times 10. That is 5 minus 5, giving me 0. Negative 1 minus 0.5 multiplying what? Negative 7. And this giving me what? Negative 1 plus 0.5 times 7. Yes, that is 2.5. So I'm getting 2.5 here. Then at this level here, I'm going to put here is 5. Okay, so I'll get 5 minus 0.5 multiplying what? 0. And obviously I'll get 5. So at this point, I've been able to eliminate my first column entries here. So I'm moving into the inner. But before then, I said we are dealing with partial pivoting. So at any instant, compare and choose the largest size entry. Okay. So the entry here with the larger magnitude is going to be what? 2.5. Okay. So this 2.5 here, you can see it's bigger than this. We don't consider outside. Whenever you are done eliminating these two, just focus on the 2 by 2 here. So I'm going the 2 by 2 here. Though this is 5, this is 6, but our interest is always here because this is where we are going to eliminate. Okay, so here you can see 2.5 is bigger than this. So you have to move this whole row up and bring that one down. Okay, so we are going to get this 10 next 7 0 0 2.55. Then here becomes 0 negative 0.0016, right? So this, we have done a row operation, which is row 2 switching with row 3. That's nice. At this point, we just have to eliminate what? Our negative 0.001. We can do that by finding our multiplier, giving us negative 0.001 all over 2.5 times root 2. So here becomes our new pivot row, row 2, and here becomes row 3. So at this point, what is this? Negative 0.001 over 2.5. So you can maintain it this way. So my row operation is row 3 minus the expression negative 0.001 over 2.5 R2, all going into row 3. So I simply have 10 next 7, 0, 0, 2.55, 0. Then obviously, normally this one will go away because you get negative 0.001 minus what? This side, negative 0.001 over 2.5, multiplying your R2, which is for 2.5. So obviously this and this will cancel, and I'll have this plus this, so here will be 0 as well. Then the most important part is this 6 part. So now I'm going to have 6 minus this one, negative 0.001 over 2.5, multiplying, here is 5. So you realize that 2.5 will go here, 2 times this. I'm going to have 6 plus 2 multiplying 0.001, which is same as 6.002. Is that not it? Yep. And now we are done with our void elimination. So we are halfway, or we are almost done with our answer. So at this point, we can find the determinant of this new matrix. We can call it matrix B. And the determinant of matrix B is given as 10 times 2.5 times 6.002. Is that not it? So this gives me 2. Let me multiply them. 6.002 times 2.5 times 10. So that gives 150.05. 150.05. 150.05. Okay. So now, if the determinant is 150.05, but you in the question when we started, I said the theorem is saying that if your if your matrix B start that it's a result from switching one row with another row, then the determinant of B is equal to negative of determinant of A. Yes, so that should tell you that to find the actual determinant of this A, I have to negate the determinant of my resulting matrix. So my determinant of A is simply equal to negative determinant of B, and it's equal to negative 150.05. And that is the end of this video. Thank you for being with me. Please don't forget to subscribe, like, and share.